Chapter 11, randomness, in terms of collecting data. If we want to generate data that gives an accurate picture of the world, we must rely on randomness. We can get random numbers through random number tables, computer number generators, the calculator, which kind of ties in with the computer one, but your calculator actually has a function to give you a random number, and dice, etc. So there's many others, but those are a few options of where you can pull a random number from. So when we are building a simulation, we use randomness to predict the outcome. And there's going to be 7 steps that go with that. So 1, we are going to identify the repeated component. Two, we want to explain how you will model the component's outcome. Three, specify how you will combine components to modify a trial, or model a trial, sorry. 4, state clearly what the response variable is. 5, run several trials. 6, collect and summarize the results of the trials. And lastly, state your conclusion in context. And we'll look at an example of doing these 7 things. All right, so a candy company is giving away A prize to consumers who collect a red, a white, and a blue game piece from their candy bars. Each bar has one game piece in it. %50 of the pieces are red. %40 are white. And 10% are blue. Conduct a simulation with 3 trials to predict how many bars you would need to buy to win the prize. Now, obviously, the minimum you would have to do is 3 because, you know, you need 3 bars to get all 3 pieces. But we're trying to figure out, like, kind of sort of on average, how many would you have to buy to actually get it. So, looking at our steps, identify the repeated component. So what is the repeated component in this example?
You mean like...
Or like what are we looking for in every...
Candy bar, different color.
Yeah.
Pieces.
Yeah, the game
That's what
piece.
I'm saying.
So the component that we're looking for is 1 game piece in each bar. Let me see. I need something here that goes with this. If I don't have one, I'll do something else. Okay. I don't have one copied at the moment, so I'll have to do one in a minute. Alright, so on your calculator, there is, to think about where it is. I have to think about what it's called, I should say. Okay, I found it. On your calculator, and Ethan, I'll give you mine once I show you how to get there.
I got a calculator app on my phone. Can I use that?
It won't work.
It won't work.
No, it's an app on the phone or on the calculator that you have to have. All right, so there's a button that says apps. It's purple, or at least on mine it's purple. So if you click that, it's going to bring up a whole bunch of different stuff here. You're looking down for the one that says probability simulator or probsim or something like that. So you're going to hit enter on that one when you find it, and they are in alphabetical order. And it's going to open up a probability simulation thing. It can do coin tosses, it can roll a dice, it can pick marbles, there's a spinner you can spin, it can draw cards, like a deck of cards. Also, if you don't know anything about a normal 52 card deck of cards, I would suggest at some point you get out a deck of cards and look at them, because we will use that a lot coming up here going forward. But then what we're looking for is the random number one. You hit enter, and every time you hit enter, it's going to draw a set of random numbers. It may ask you for some information first. You can set the numbers to range.
Mine is not entered.
What is happening? Why is this not working? Escape. Okay, so it's working now. So it let me see. Does yours have the set options?
Yeah,
If you hit
and I
set.
did 1 through 10.
Okay. Yep. And yes to the repeat question.
Okay.
So I will also show you when we're done, when I can go print off random number tables, how we would do it on that if you were given that. But I personally like using the calculator, just it's easier to use. But on the AP test, they may just give you a random number table and tell you to use that on the non-calculator part. So I'll go over both. But we are going to, for part 2, it says to explain how you will model the components of the outcome. So we are going to use the calculator random number simulator. And so we are going to use the digits 1 through 10. If you were using a random number table, we would use the digits 0 through 9, and we're using single digits. Okay? Because you're doing it on your calculator, you can technically pick any numbers that you want, but that's the easiest. So, and the reason I've chosen 1 through 10 is because 50% are red, 40% are white, and 10% are blue. So those are going to associate with how many digits align with that. So 50% of the pieces are red. So half of my digits 1 through 10 are going to be red. So we're going to say that digits 1 through 5 are going to be red. So if when you hit roll, it rolls a 4, okay, that's red. Okay, so we're trying to see how many times do we have to run until we get all the ones that we're looking for. Okay, so then it says that 40% are white, so that would mean that 7 through 9 are going to give you white, or sorry, 6 through 9, not 7. So 6 through 9 are going to give you white, and then the last 10% that are blue. So we would say that the number 10 is going to give you blue. Now, I'm just gonna write a little note over here because it depends on what we're doing if like we can have repeats and stuff. So I'm just gonna write a little note thing here about this. The numbers will match the percentages, so that's what we already talked about. And then we need to specify stuff like, will some numbers be ignored? Do you need to ignore repeats? And then if we had percentages that said like 33% are red, then we would need to use double digits. For non-10 based percentages. So if we were doing a random number table, we would only use like 0 through 9 instead of 10 because that would require 2 digits. So we're trying to use all the digits rather than numbers. If we had to do double digits, because of like the 33% on the random number table, we would have to use like 0, 0 or 0, 1, 0, 2, you know, things like that, for those 2-digit ones. So I'm just going to also note here that if we used a random number table, we would use single digits 0 through 9. I have a random number table, but it's written on, so your book actually has a random number table in the back. That's what I will copy and give you for like tests and stuff if you need it. But again, I'm okay with you using the simulator on your calculator to run the numbers. So, all right, so then step 3, it says to specify how you will combine components to model a trial. So for this one, we would say something like, for each trial, I will continue choosing numbers until I have a red, a white, and a blue piece. Then step 4 says to state clearly what the response variable is. So what is the response variable?
How many times you have to like roll like get
Yeah, the number of times until complete. So count the number of trials until complete. Five says to run several trials. We always want to do a minimum of 3. So run 3 trials. There are going to be some where we actually do 20 trials. That's
Oh
the
my
best. That comes in a later chapter, but we actually talk about 20 is really what you want to do to get accurate information. So we are going to run 3 trials. So we'll have, red, white, blue. Now, if I was using a random number table, I would underline in colors what each of the things are. Okay, so like I would get like 3 markers out and I would list off something like this color is red, this color is white, and this color is blue. And every number that you go to underline, I would underline in that color. So how we said 1 through 5 is red. So any number 1 through 5, I'd underline in red. That just helps you to go back and make sure you got, especially with something like this that cares about the color of it. That helps. But since you're doing it on your calculator, it's not quite as relevant because you're just going to be looking for the numbers. So we're going to run the simulation. So trial 1. So this is completely dependent on what your calculator gives you. Okay, so you're going to run the trial, and you have to run it until in that trial you get 1 number out of each category. So you need 1 number has to be in the range of 1 to 5. 1 needs to be 6 through 9, and then one of them has to be the number 10. So once you have 1 number out of each of those categories, you got it. So you're counting how many trials you do until that happens.
You're only supposed to have 3 numbers, right?
No, it can be however many's in the.
'Cause I had
So you're looking for how many times do I have to run it until you get it.
Okay, I got it.
So how many trials did it take you to get it?
1.
You got it on the first one?
Yeah.
So your first one would be 1 trial until complete.
How you generate the number?
Just hit enter.
Which one do I
So you're looking
have?
for,
First one? 3. So it's right here.
you have all the numbers?
I got 6 numbers.
I know. You have 1 number out of each category. If you have a number that's in the category 1 through 5, you have one that's 6 through 9,
Oh.
and one that's the number 10. Okay, so you're going to keep hitting enter until you get that.
Yeah, because I have 4, 10, 1, 9, 7, 3.
Alright, 2.
So at second trial, you got all 3 in that 1 trial. Okay. So then yours would say 2 instead of 1. Okay, so these questions, when you get to a test or a quiz, they're subjective because it depends on what you got. So then we're going to run it again. So you're going to run the trials again and see how long it takes you to get.
Okay, I got it again.
In 1.
Yeah.
Wow.
I have 10, 8, 4, 3, 10, 10. Stupid number 10.
This is the 10th one.
Last year we had one, it took 14.
You.
Alright. I got it. After 10 tries.
10? So I'm just going to, just because it's different. Now, obviously, you're doing it exclusively for yours, but since I don't have one, I'm just doing whatever, y'all tell me. And then trial 3, so you're going to run it again.
No shot. I got it again in the first one. 1, 2, 7, 10, 7, 4.
Oh, first try.
You got all the first one?
That's funny.
But part of that is also why we would run more than 3 trials. But now, technically speaking, if you go back to that set thing, there's an option to choose only 3 numbers.
Yes.
We probably really should do with just 3 numbers.
That's what I've done.
But for the sake of what we were doing, it's fine. That'll also make it significantly less likely that you get it in one trial that often. But it's fine for what we were doing right now.
Like you buy 6 candy bars every time you go to the store.
Yeah, exactly. All right, the next one is us to summarize. So we want to know the mean number of trials that it took. So we would add these 3 numbers up. So add whatever you got up and divide by 3 and tell how many trials it took.
Okay, how do you get out?
Hit second quit, and then it'll ask if you're sure you want to leave.
Mine is not letting me. Second mode. It's over the top.
If not, look at the, let me see.
Oh wait, I found it.
I was gonna say,
Escape.
sometimes there's an escape button and sometimes you have to actually hit second quit.
How many times you say
It's one of the 5 buttons at the top. You see at the bottom it's got,
It's at the bottom, but like how do I get to it?
yeah, you click the top gray button that's with it, that lines up with it. And then I'll say like, are you sure you want to leave? Cause it'll clear your data if you leave, so. So you would take however many trials you got for each one, add them up, divide by the total number of trials that we ran. Okay, so like trial 1, trial 2, trial 3. So you'll divide by 3 after you've added them all up. So like Joelle's, yours should be 1. And then I don't remember what yours is. 4.3. So the median value, so it's like in the middle. So again, it's 2. And then the max number of trials it took. So I'm just gonna say 10 for this particular case. The min. One. So yeah, and I mean the minimum is, you would want to list it for your set of data, but what I will often do is say, but it could be this. So like let's say that all of them had taken 3+ tries. I would say the minimum number of trials that I would have to run to get it is 1, because that's the only possible way I can get 3 candy bars that, whatever. So with this stuff, obviously, if we want to be more confident, we would complete way more trials. Something like 20 trials, probably. So that's where I was saying, like, you would want to complete a lot of trials in order to figure that out. So then part 7 is to state your conclusion. So you would say something like whatever your average is. So on average, you need to buy, and then however many candy bars to get all 3 game pieces. However, to be sure, you might need up to blank bars. So this would be your max value that's going in that blank. So like it could be, like in this case, mine would be 10 and 4.3 based on what I put from his numbers.
So.
Now, this is the thing. Because of what we're working with and talking about simulations, you can't do a third of a simulation. Okay? So when his number came out to 4.3, what we really need to say is we need to actually call this 5. Okay? We need to round up. Okay? Having a third of a trial is not possible. Okay? So I would just note that be careful in simulations not to report. I'm going to do, just since we just use it, 4.3. Or, well, be careful in simulation not to report. And then I'll say something like, you need to buy 4.3 bars. Okay, that is impossible. You can't just buy a third of a bar. Round up. So we would want to change that in there to 5. So it doesn't matter. Normal rounding rules do not apply. Anything over the whole number rounds to the next whole number. I don't know if y'all ever watched the Andy Griffith show, but there's at one point where they're talking about 3.5 boys live in, or don't have a winter coat or something like that. I don't remember exactly what it is. And he was like, I just don't understand. How do you have a half a boy? It's like, well, you don't. It's a ratio. But if we were actually talking about it, you would have to round up and say 4 because you can't have a half of a person. So it's the same kind of thing here. And then lastly, simulations are used frequently to check the likelihood of a given outcome. And that is actually all the notes for this chapter.